this video, I want to talk about the complex numbers. A complex number in rectangular form can be written as, let's say, z is equal to a plus jb, where j is equal to a square root of -1. And in a complex number, this portion is called the real part of the complex number, and this is the imaginary portion of the complex number. So if we assume this to be our imaginary axis and this to be our real axis, and let's say this is our A and this is our B. So here this is our A and B. So here we have a right triangle that the hypotenuse, we can call it the absolute value of z, which is equal to a square root of a squared plus b squared. Now, this is the rectangular form of a complex number. We can convert this into the exponential form, and in order for us to convert that to exponential form, let's go ahead and multiply. Let's go ahead and multiply and divide this equation by a square root of a squared plus b squared. So let's go ahead and multiply and divide this by a square root of a squared plus b squared. So we can write it like this. Now, if we look at this right triangle, a divided by a square root of a squared plus b squared. If we call this angle theta, so the cosine of theta will be equal to a divided by a square root of a squared plus b squared, and the same, the sine of theta will be equal to the opposite side, which is b divided by hypotenuse, which is a squared plus b squared. So that means this portion is cosine of theta, and this portion is the sine of theta. So we can write this formula as cosine of theta plus j sine of theta. Now, if you remember the Euler formula, says that e to power j theta is equal to cosine of theta plus j sine of theta. So in fact, this is the Euler formula. So that means this is equal to e to power j theta. So this means this is equal to e to power j theta. So this, the hypotenuse, we can show it as absolute value of z. So this can be shown as absolute value of z multiplied by e to power j theta. So this is our z, our complex number in exponential form. Now, in these steps, we just learn how to convert a complex number from a rectangular form into the exponential form. Now, if we have an exponential form and we want to convert it to the rectangular form, what we do, we use the Euler formula. We can write this as absolute value of z multiplied by cosine of theta plus j multiplied by absolute value of z multiplied by sine of theta. Now here we say cosine of theta is, this is in fact a divided by absolute value of z. So from here, from the cosine formula, we can see that a is equal to absolute value of z multiplied by cosine of theta. And this is absolute value of z multiplied by cosine theta. This is our a part. And from the sine formula, which is b over absolute value of z, from the sine formula, we can see that b is equal to absolute value of z multiplied by sine of theta. So this is absolute value of z multiplied by sine of theta. So we can write this as a plus jb. Now we learn how to convert a complex number from the exponential form into rectangular form. And why do we want to do that? In any formula that we start to deal with complex numbers, the rectangular form is the best and the easiest way for addition and subtraction, and the exponential form is the best and easiest for division and multiplication. So any time we are dealing with complex numbers for addition and subtraction, we should convert our number into rectangular, and for division and multiplication, we have to convert our complex number into the exponential form. So let's, now that we learn how to convert one to other, let's just look at the addition and subtraction. Let's say we got two complex numbers. One, we show it as z1 is equal to a1 plus jb1, or in rectangular form, or in exponential form, we can write it as absolute value of z1 e to power j theta 1. And we have another number z2 equal to a2 plus jb2, which we can write is an absolute value of z2 multiplied by e power j theta 2. Now let's say we want to go ahead and multiply these two numbers. If we want to multiply these two numbers, if we want to use the exponential form, z1 times z2 will be equal to absolute value of z1 times absolute value of z2 multiplied by e to power j times theta 1 plus theta 2. Done. Now let's do the same thing using rectangular form. If we want to multiply using rectangular form, it's going to be a1 plus j b1 multiplied by a2 plus j b2. So if we multiply these two, we are going to have a1 a2 plus j a1 b2 plus j b1 a2. J times j is minus 1, so minus b1 b2. So if we simplify that, we can write this as a1 a2 minus b1 b2 plus j multiplied by a1 b2 plus b1 a2. So you can see the exponential form is a lot easier than the rectangular form in multiplication, and there is less chance of making mistake. Now let's do the division. The division of using the exponential form, we are going to have z1 divided by z2 is equal to absolute value of z1 divided by absolute value of z2 e to power j theta 1 minus theta 2. Now if we want to use the rectangular form for division, we have to do a1 plus j b1 divided by a2 plus j b2. So let's go ahead and multiply the top and bottom. So this is z1 divided by z2. Let's go ahead and multiply the top and bottom by a2 minus j b2. a2 minus j b2. So here we are going to have a2 squared and j times j is minus 1 multiplied by minus is plus b2 squared, and on top we are going to have a1 a2 minus j a1 b2 plus j b1 a2. J times j is negative, negative times negative is positive, plus b1 b2. So if we simplify that, this will be a1 a2 plus b1 b2 plus j multiplied by b1 a2 minus a1 b2 divided by a2 squared plus b2 squared. So you see, it's a lot easier again to use the exponential form for division, and for addition, the rectangular form is the best for addition. So z1 plus or minus z2 will be equal to a1 plus or minus a2 plus j b1 plus or minus b2. And now if we want to do addition and subtraction, we can just look at it using the exponential form. It's going to be hard. So the best for addition and subtraction of the complex numbers is the rectangular form, and the best for division and multiplication is the exponential. This you will use it all the time in research. I hope you